Imagine a world that is hauntingly familiar, a place with thick clouds, drifting rain, flowing rivers, and vast, calm oceans. If you stood on its surface, you would see mountains rising in the distance and feel a solid ground beneath your feet. It looks almost exactly like Earth, but it is a lie. The rain isn't water, it is liquid methane. The rocks are not stone, they are ice frozen, harder than granite. And the mountains? They are giant blocks of frozen water. This is Titan. It is the only other world in our solar system with stable liquid on its surface. It has a weather cycle, seasons, and a landscape that mirrors our own. But beneath those orange, hazy clouds lies a mystery that scientists are still struggling to understand. Because in this strange, frozen version of Earth, the chemistry suggests that the ingredients for life are already there, waiting for a spark. For centuries, Titan was nothing more than a point of light. Even when we officially discovered it in 1655, we had no idea what it actually was. We knew it was big, larger than the planet Mercury, and 50% wider than our own moon, but it kept its secrets well. Our first real chance to see it came in 1979. NASA's Pioneer 11 probe swept past Saturn, ready to capture the first close-up images of its largest moon. Scientists were expecting a cratered dead rock. Instead, they saw a featureless orange ball. Titan was wrapped in a dense, impenetrable smog. It was frustrating, but it was also a major clue. That haze meant Titan had an atmosphere. In fact, Pioneer discovered that this atmosphere was thick, nitrogen-rich, and remarkably similar to Earth's. But it wasn't just nitrogen. The sensors picked up something that shouldn't have been there in such vast quantities: methane, natural gas. On Earth, methane is a byproduct of life or geology, usually destroyed quickly by sunlight. On Titan, the sky was full of it. This discovery changed everything. If you have nitrogen and methane and you bombard them with solar radiation, you get complex hydrocarbons, the building blocks of biology. You get the foundations of DNA, proteins, and cells. Titan wasn't just a moon. It was a prebiotic laboratory on a planetary scale. But to find out what was cooking in that lab, we had to find a way to see through the clouds. It would take 25 years for technology to catch up. In 2004, the Cassini spacecraft arrived at Saturn. This wasn't a flyby. This was an invasion. Cassini carried powerful radar and infrared scanners designed specifically to pierce Titan's veil. What it found beneath the haze was shocking. Titan is the only moon in the solar system with a substantial atmosphere, 4 times denser than Earth's. This creates a reverse greenhouse effect. The haze blocks the sun's heat, dropping the surface temperature to a staggering minus 179 degrees Celsius. At this temperature, the laws of physics we know on Earth are twisted. Methane, which is a gas in our tanks, turns into a liquid. Water, which flows in our oceans, freezes so hard it behaves like bedrock. Cassini's radar began mapping the surface, but the real test was yet to come. Attached to the side of the spacecraft was a smaller probe named Huygens. Its huygens was a suicide dive. It would detach, parachute through the violent winds of Titan's upper atmosphere and land on the surface. In January 2005, Huygens dropped into the orange abyss. It had 3 hours of battery life to justify decades of work. As it broke through the cloud deck, the camera revealed a landscape that made the mission scientists gasp. They saw dark valleys carved between bright mountain ranges. They saw drainage channels hundreds of meters wide cut into the hillsides. These weren't ancient scars from billions of years ago. These were fresh. It looked exactly like a coastline on Earth. The data suggested the probe was descending toward a shoreline, perhaps into a liquid sea of methane. But as Huygens neared the ground, the liquid wasn't there. The probe slammed into the surface with a dull thud, sliding 30 centimeters before coming to a rest. It hadn't landed in an ocean. It had landed in a desert. But looking at the photos sent back, the mystery only deepened. The ground was littered with rounded stones. On Earth, stones only get that smooth, round shape from one thing: tumbling in a flowing river for thousands of years. Huygens was sitting in a dry riverbed. The rocks were chunks of water ice, and the dirt was a soft, snowy hydrocarbon grit. The humidity was rising. The ground was damp. Every piece of evidence screamed that a massive river had just been there. So where did the liquid go? The answer lies in Titan's bizarre methane cycle. On Earth, sunlight drives evaporation quickly, creating frequent rain. But Titan receives 1% of the sunlight Earth does. Evaporation is agonizingly slow. The moisture rises, forming massive, dense clouds that hoard the methane for centuries. Titan experiences mega droughts that last for hundreds of years. But when the rain finally comes, it is a apocalyptic. The sky opens up and liquid natural gas pours down in torrential flash floods, carving those river channels and smoothing those ice stones in a matter of days before evaporating and leaving the surface dry again for another century. Huygens had simply arrived in the dry season, but Titan wasn't entirely dry. As Cassini continued its 13-year watch, it scanned the polar regions and found what Huygens missed. Near the North Pole, the radar pinged back surfaces that were perfectly flat. Lakes. Titan has lakes and seas of pure methane and ethane. The largest, Kraken Mare, is bigger than the Caspian Sea, but these seas are eerie. Despite the low gravity and thick atmosphere, conditions that should create huge waves, the surfaces of these lakes are almost perfectly still, smooth as glass. We still don't know why. The surface is only half the story. Titan is hiding something even bigger, deep underground. Remember, Titan isn't dense rock. It's mostly water ice. As Cassini measured the moon's gravity during flybys, it noticed the moon actually flexing as it orbited Saturn. A solid ball of ice shouldn't flex that much. The only explanation is that the crust is floating on top of a liquid layer. 50 kilometers beneath the frozen surface, scientists believe there is a global ocean of liquid water, not methane. Water. But how does water stay liquid so far from the sun? The secret is likely ammonia. Acting as a powerful antifreeze, ammonia mixed with the water would lower its freezing point, keeping it slushy and liquid despite the cold. This creates a terrifyingly dynamic world. You have a crust of organic snow and rock-hard ice, liquid methane rivers on the surface, and a warm, ammonia-rich saltwater ocean below. And occasionally, these worlds meet. We see evidence of cryovolcanoes, volcanoes that don't erupt lava, but erupt icy slush from the underground ocean, spewing water and ammonia onto the surface, where it instantly freezes. This is why Titan matters. We have carbon-rich molecules raining from the sky. We have liquid water underground. And thanks to cryovolcanoes, we have a way for them to mix. When you mix complex hydrocarbons with liquid water, you get amino acids. You get the fuel for life. We aren't saying there are civilizations down there, but the conditions for primitive biology are surprisingly good. It is a world with a thick atmosphere to protect against radiation, liquid solvents on the surface, and an energy source from Saturn's gravity. NASA knows this is our best shot at finding life that is truly alien, life that evolved in a completely different chemical system than our own. That is why we are going back. NASA has approved the Dragonfly mission, a nuclear-powered dual quadcopter. Unlike a rover that crawls a few meters a day, Dragonfly will fly. It will hop from location to location, sampling the dunes, the dry riverbeds, and the impact craters where liquid water might have once mixed with the organic surface. Launching in 2028, it will arrive by 2034. It will finally answer the question that Pioneer, Cassini, and Huygens started. Is the most Earth-like world in the solar system also the only other living one? Titan challenges our definition of what a habitable world looks like. It proves that nature can build the same landscapes, rivers, rain, and seas out of completely different materials. It is a frozen mirror of our own planet, waiting to be understood. If you want to see more deep dives into the mysteries of our solar system and the engineering it takes to explore them, make sure you're subscribed. There are missions launching soon that will change everything we know, and you won't want to miss what comes next.